In this video, I just want to go over a few algebra tips and how to do some beginner level algebra and how to make it easy for yourself so as you continue throughout your math journey, you don't forget this stuff or um, you develop bad habits, something like that. You just want to develop good habits and make sure to understand the fundamentals. So the first thing you should know is how to add like terms. Now, first you need to know what is a like term. Well, a like term, I like to imagine this like a number line. So let's say we have a number line here. Well, what would you put on a number line? Obviously numbers, right? And we start at 0 here, or the middle is 0. So we have 1, 2, 3. So this is a real number line. All of these numbers are real numbers. So if I told you to add 2 plus 3, you would tell me 5, right? Now, what if I gave you a different number line from a different world? The world where all of these numbers are variables of x. So we have x, we have 2x, 3x, and I told you to add 2x plus 3x. What would you do? Well, you would add it like 5x, right? Nothing too crazy. But what if I told you to add 2 and a 2x from the two different number lines? That wouldn't make sense, right? They're on two different number lines. They're from two different worlds. They're not like terms. We have values multiplied to this x variable. These are like terms. And then we have real numbers up here. Now, this becomes more clear if I add another number line. And now we have variables with y attached to them. 2y, 3y. Now, I wouldn't tell you to add 2x plus 3y. That wouldn't make sense. Like, what would you get out of that? Nothing. This is the final answer, 2x plus 3y, because you can't really add them together. 2 and 3 are alike because they're real numbers. 2x and 3x are alike because they're part of the x variables. And y and x are not alike because they're two different variables. Now, what tends to trip people up at the beginning is powers. Now, we know powers are just written something like this. Like, let's say we have x times x times x. We would say this is x to the power of 3. Just like we would say 2 times 2 times 2. Sorry, that looks like a z. 2 times 2 times 2 is equal to 2 to the power of 3, or 8, right? So 2 times 2 is 4, times another 2 is equal to 8. Now, if I told you to add or collect, let's say I give you an expression and I tell you to collect like terms, right? So what if I say 3x plus 5x plus 2y plus 7 minus x squared is equal to 0. And I say, okay, collect all the like terms in this problem. I hope you don't want to, and it's okay if you do because this is a beginner algebra video, add x squared and x. Would you add 7 to 3x? No. Then why would you add x squared to x? This is x, and this is x squared. They're different things. They're not alike. And if you ever forget, just ask yourself, are they alike? Remember the number line. Remember that in math, things are very particular and exact. You can't just be going around adding x's because they look the same. They're completely different, right? So let's add like terms. So we see that 3x and 5x are like. Is anything else x? So 2y, that's not an x. We have a real number, not an x. X squared, not an x. Okay, so we can add them together. So 3 plus 5, 8x. Next, we move on to 2y here. Is anything else y in this problem? No. Okay, so we just add it on. Same with 7. Is anything else 7 in this problem, or a real number in this problem? No. So we just add it on. So plus 2y plus 7. And now we have x squared. Nothing else is x squared, so we just add it on. Simple, right? So now, what if I gave you something that looked like this? 2x plus 2x squared plus x squared is equal to, add like terms here. Well, is anything x? No, so we just put the 2x. Now we have x squared. Well, we have 2x squared here. Is there anything else that's attached to the x squared? Oh, we have 1x squared. Great, they're like terms. That means we can just add them together, right? So 2x squared plus 1x squared is 3x squared. Pretty simple, right? The next thing I want to go across is, how do positives and negatives interact with each other in addition, subtraction, division, and multiplication? So let's say we have a positive 2, and we would like to add a negative 2 to this positive 2. Now, the fact that I said add a negative confuses some people. But in reality, to add a negative to a positive just means to subtract, right? But what if I said, so we would know that this is just 0. But what if I said we have a negative 2 and to add another negative 2? Now what? How do you add a negative to a negative? Just like you would add to a positive, right? So if I were to give you a number line here, and we had 2 and 3 and 4, and I said, how would you get from 2 to 4? You would say, oh, we add 2 to get to 4. What if I wanted to get from negative 2 to negative 4? Would you add 2? No, you would add negative 2, right? Just as we're doing in this problem. If you added 2, you'd be back at 0. We're adding negative 2, and that's how adding a negative works intuitively. It's on the left side of a number line. It's a whole different set of numbers. So when adding a negative, we add it just as we had positives. So what happens if we are multiplying now? Let's move on to multiplication. So I clean this up. Let's move on to multiplication. So a couple rules I just want to get down before we even do anything. A negative multiplied by a negative number is equal to positive. A negative times a positive is equal to, of course, a negative, right? You can verify this on your calculator. But if you want to go quickly and understand it, at the end of the day, this is how it is. Let's say we add, or we multiply 3 negatives now. What would that equal? 3 negatives. That's a lot of negatives. Must equal negative. And you're right. But we notice here that 2 negatives equal a positive, right? So let's replace the 2 negatives with a positive, and then we have that multiplied by a negative, and we can see that it equals a negative. At the end of the day, always consult the fact that two negatives equal positive, and that a negative times a positive equals a negative. Because no matter how many negatives you have multiplied together, you can always reduce it using these two properties, right? So let's put that into practice. If I said multiply -2 times a -3, please don't say -5. Consult the properties. We have -2 times -3. Two negatives make a positive. When you're multiplying, remember if we were adding, of course with this would be -5. But since we're multiplying, two negatives make a positive. Just have that in your head. Two negatives make a positive. -2 times -3 is equal to 6, positive 6. Now, if I said -2 times positive 3 now, what would that equal? Good. -6, because a positive times a negative is equal to a negative. Negative overpowers the positive. And when you have two negatives together, we create a positive. Now, what about division? What about division? Now, division is a little bit more tricky, I think. I think it's more tricky, and I think it's easier to make mistakes when doing algebra and using division and not knowing, not being quite familiar with everything yet. So let's say if I had a negative divided by a positive. Actually, let's make this all equal to 1. So a negative divided by a positive. Now, you know 3 divided by 3 is equal to 1, right? But what is the sign? What is the sign? Consult the multiplication table. A positive and a negative is equal to negative. So this would be -1. Now, likewise, if I had -3 times divided by -3, what would we get? Well, now we have two negatives, and two negatives make a positive. So this would equal to positive 1 instead of -1. Great. Now that you know that, let's try and trip you up. What if I had 3 divided by -1? Now you might be saying, well, every number is divided by 1. Well, I'm saying this one's divided by a -1. What would that be? Now, of course, you can verify in your calculator, but intuitively you should know as well. Well, that's just equal to -3. It doesn't matter where the negative is, on the denominator or the numerator, it doesn't really matter. Just know that two negatives make a positive, and a negative divided by a positive or a negative times a positive always equals to 0. Always equals out to be a negative. And remember, if you have a bunch of negatives or positives and negatives multiplied consecutively, it can get a little confusing. So always reduce it using the rule that two negatives equal positive, or that negative and positive are equal to negative. So let's reduce this. It's -3 times -4 times -3 times a positive 4. How are we going to reduce it? Two negatives equal positive. So what's -3 times -4? 3 times 4 is 12. Then we have a positive and a negative right here. So that's obviously negative. So that's times a -12. And now we're going to end up with 12 times a -12. And that just looks pretty normal. And we're going to say 144, right? Simple, easy as that. You can even confirm it in your calculator if you want, like I'm going to right now, so I don't mess up during the video. Right, -144. So that's how you deal with positive and negatives when you're adding, subtracting, multiplying, and dividing in algebra. Another thing that confuses people in algebra are brackets. where to put them, when to use them, when to distribute. I don't know. Relax. Just follow bedmas and follow the fact that positive times a negative is equal to a negative, and a negative times a negative is equal to positive, and you won't mess up. Right, so let's get some brackets here. So let's say we're given 6x plus 4x squared minus 2 minus another bracket here. So minus 6x minus negative 6x plus 4x minus 3x squared. So we have two trinomials here. We have a bracket here and a bracket here. Now, the first thing you're going to want to do is rewrite this question, but distribute this negative into the bracket. Now, when you distribute a negative into the bracket, a lot of changes are going to occur because of the following rules and properties, following properties we just talked about, right? Let's say if this was positive, if we distributed this into the bracket, like really nothing would happen, right? This would still stay negative, this would still be positive, that would still be negative. But since in this question it's a negative, all these things are going to change. So let's rewrite it. 6x plus 4x squared minus 2. And we have a bracket here, so we must distribute this in before adding these two trinomials together. So let's distribute the negative in. Negative times a negative 6. Now it's a positive 6x, sorry. Negative times a positive. Now it's a negative 4x. Negative times a negative again. Two negatives make a positive. So now it's a positive 3x squared. And now we go back to the first thing we learned in like terms. So let's figure out what's like. Well, we have a 6x here. Is there any more x's? Yes, another 6x. And a negative 4x. Great. So 6x plus 6x, that's 12x. And we need to minus 4x. So that's equal to 8x. Good. 8x. What else is like? Oh, we have an x squared here and an x squared here. Great. Let's add them together. So 4x squared plus 3x squared, that's 7x squared. Okay, negative 2 on its own. There are no other real numbers. So minus 2. And that's it. That's the entire, That's the entire problem. We did it. We distributed a negative into a bracket. We added two trinomials. We collected like terms. And we touched up on our algebra. Great. All right. The next thing that is very important to know, and that most students make a tremendous amount of mistakes on, are multiplying powers with different bases. What do I mean by bases? Well, I mean that x squared has base x and y squared is base y. Okay? So, how do we multiply powers? Do you remember how we couldn't add x squared plus x cubed or plus x? We couldn't add these because they weren't like terms. Well, guess what? We can multiply them. We can multiply anything together. But how it's oriented and how what is outputted does change. So let's say we had x squared times x cubed. We can't add these together, but we can multiply together. And how does that work? Well, when you multiply the same variables of the same base, you have to add the powers together. So if I said x squared times x cubed, this would actually be x squared plus 3, so it'd be x to the 5th, not x to the 6th. You do not multiply them together, you add them. That's why I use 2 and 3. Now, what if we had x squared times x cubed, same thing as before, times y squared. Oof, different base. Different base, different variable. Just because these are the two have the same power doesn't mean we can multiply them together. And by the way, none of these are like, so we can't add them together either. But we can multiply them together in a certain way. So these are like bases, and we already did this. This was x to the fifth power, right? Because we add the powers. Now, how do we add this y? How do we multiply this y to it? Well, you just attach it to it through multiplication. And you might say, what is the point of that? Well, this keeps our algebra intact in future problems, or when we're solving for different variables, because then we know it's multiplied. It's connected through multiplication. So if we wanted to solve for it, we would divide, right? So let's demonstrate that. If we had x to the fifth power times y to the second power is equal to 2x plus 3x minus y, I'm going to say solve for x of the fifth power. What do I mean by solve for? By solve for, I mean isolate it on one side of the equation and have everything else on the other side of the equation. So naturally, you would want to instantly move everything on the left side of the equation here, because x to the fifth is there, to the other side. But first things first, you must collect like terms, because it just makes things easier. So let's do that. So we have x to the fifth, y squared, that's not a very good y squared is equal to, okay, we have like terms here, 2x and 3x are like, so add them together, 5x. Is anything like with y? Nope, so just keep it there, minus y. Now we're going to solve for x to the fifth. So y is multiplied with x, connected through multiplication. So how would we get that on the other side? Well, what if I divided by y to the y squared here? Well, these would cancel, right? So what you do to one side, you must do to the other side. So I'm going to divide by y squared on the left side. So I'm also dividing by y squared on the right side. These cancel, and now we have x to the fifth all alone, just like we wanted. Amazing. Next thing I want to look at are square roots. So let's say I had x squared plus y squared plus 9 is equal to 0. And I said solve for x. Well, you might tell me there's no x in this problem. There's only an x squared. Right, exactly. So let's solve for x squared. So x squared is equal to negative 9 minus y squared. Now, how do we make this just x? We square root both sides. What you do to the left side, you must do to the right side. Now, what is a square root? The square root of x is actually just x to the power of 1/2. X to the power of 1/2. That's all the square root is. So let's look at this algebraically. Pretend we square root both sides. So we have x squared. So what is a square root? It's x to the power of 1/2. So over it, we have 1/2. And on this side, we have negative 9 minus y squared and to the power of 1/2, right? Square root. Well, what if we multiply this 1/2 into our bracket here? Remember, this is not multiplying powers with the same base. We are now dealing with brackets. Inside the bracket, we have x squared. On the outside of the bracket, we just have x squared raised to the power of 1/2, which is a square root. So it's treated completely differently. Now that it's on the outside of the bracket, it's connected through multiplication. So when we multiply 2 times 1/2, We get 1, right? The 2's cancel, and it's just x. And now we've solved for x. And that's about all I'm going to cover in this video. In part 2, we're going to go over the FOIL method, some factoring, some other cool stuff. So make sure to subscribe if you liked the video. If you hated the video, don't subscribe, but leave me a constructive comment that tells me how to make these videos better, because this is the start of my content creation and I just want to know how to make this stuff better. Thanks for watching. Have a great rest of your day.